Okay, so hopefully our volume is okay. And yeah, we do. Wow, this is super bright. I need to adjust the lighting a little bit. Yeah, this might be slightly better. Okay, so former Student Team Delft is about to do a design release for their DUT 21 car, I'm assuming. So this brightness, well, I guess it doesn't matter that much. I mean, we're here to watch the design presentation and not my face, so it's fine. Just firing up a laptop here so I can check this stream here a little bit closer to me while I watch this, because the the stream that this streaming computer is capturing, that screen is like way over there. So, well, I could actually, yeah, I think I can actually watch this. I'll just pull it up on this laptop here just to be sure. What's the name of this design presentation? DUT 21. Presentation. Let's see if, yeah, okay. YouTube does find that perfect. Okay, so watching that over here on the laptop also. Hello? Okay. Okay, I guess you guys do hear this mic. Okay, the volume does seem to be reasonably good, so we are okay. Let's turn off that. I think we are live already, just waiting for the design presentation to start, which will apparently start shortly, so that's good. So yeah, as you can see, we have their logo here, and wait, you can't see this cursor, of course. Wait, what if I move this cursor over here? Okay, it still doesn't pick up. Okay, never mind. Not sure, there's probably some way to do that, but yeah, we do have our ElmerRacing logo on there, so good stuff on that. And yeah, we've been supporting them now for a few years already, so yeah, one of the best Formula Student teams currently, probably like worldwide, I would guess. Yeah, they don't win like all the competitions, but they do have a very, very good team, and yeah, ElmerRacing logo, have to love that. Nice. Yeah, a little bit stretched out there on the logo, but it's fine. You can figure out what that is, or what company that is. So super happy. I guess they have to fit that into a specific like format, and yeah, aspect ratio for it. Okay, I think it's going to start here. So let's just see if I can make myself a little bit smaller here. Wait, so that's this thing. Yeah, perfect. Okay, firing up here. Oh wait, there's no, ooh, you don't have any audio. Wait, what? Oh crap. Wait, how do I get this audio to you guys? Oh, echo. To mute this a little bit. Audio input. Okay, I think you guys should have audio now. Okay, so I guess you have the audio now from there, so let's just follow in here. Okay, so these cars are before we started collaborating with them, but yeah, really interesting to see like where they've come from, how much they've developed, and yeah, I hope they like go through like how their whole team is set up, because that is like really like a professional setup there with a very large team and separate sectors there on how they work and like how the teams transition and like transfer knowledge over to the next team. So it's really good. Let's listen again. This car, then final compression car, we compare this car to this one. It's much smaller and much lighter. With this car, the team would succeed in winning performance in Germany. And therefore, ending. Oh, sorry about that, guys. Okay, so that live stream video is maxed out now, or the audio is maxed out that level, so hopefully it's okay for you guys. There's nothing more I can adjust here really on that. Yeah, we got involved with them, I think it was 2018 for the DUT19. We had a deal with them for the DUT20 also, but unfortunately that year got cancelled because of all the restrictions, like limiting all the events and stuff, so unfortunately that did not happen, but yeah. I actually got a fantastic opportunity to test drive the DUT19. Oh, yeah, this is starting to get very close to their modern, or like their newest car setup. So I'm not sure actually what their 2020 car would exactly look like. I did see some renderings and stuff like that, but yeah, like how that actually ends up building in reality is a different question, of course. So, oh yeah, and the active like arrow ride height stuff. Yeah, so we did do some parts for this car, so this is good. Got to drive that also. Yeah, so we did go through, so we did the hub assemblies. They have direct drive electric motors in the wheels with built-in gearing stuff with all the suspension attachment points and stuff like that. So they managed to significantly simplify that by looking at how complex parts like we're able to manufacture. So definitely help them out a little bit with that, and also for the ARM attachment pieces for the hubs also. They have these aluminum pieces where you have the carbon fiber tubes from the suspension arms like mount together, and there's really complex geometries, and we'll figure out a way how to do the mounting points for those manufacturers. So. It's time to explain what we're actually going to do with this car. Yeah, so that DUT19, I got to drive that like 2019 fall or something like that. So they set up this like test day for sponsors or something. It was really good driving that. I mean, the performance is really high on that for like compared to its size. Of course, if you take it out on a really fast track, then the top speed isn't there because it doesn't have enough power. But I mean, for the kind of tracks that it's designed to compete in, it's incredibly fast, and like it changes direction so quickly, and with the huge aero, like you have these super tight corners where you don't have that much traction, but then when you're accelerating on the straight with it, because the faster you go, the more downforce it has. So I think they said that they also have like the power application is like ramped up according to the traction limit also. So when you're accelerating out of the corner, it starts accelerating faster because you're picking up speed, so you have more downforce and traction, so you can apply more power. That's like a very strange feeling when you're like accelerating out of a corner with like full throttle, and it starts accelerating faster and faster, and then you don't really know like when do you need to slam on the brakes to like do a small hairpin or something. So but yeah, it was super interesting. I mean, there are always lots of things that can potentially be improved. So I think the torque vectoring is, or suspension geometry, maybe could like use a little bit of tweaking. But this again, of course, if you get used to it very well, then let's listen again. Yes. Yeah. Yeah, so the overall formal... Wait, why is this... okay, this is... Okay, I think this... Oh no. Lost audio from the stream again. This is not ideal. Okay. Should have audio again. Sorry about that, guys. Yeah, so the whole Formula Student concept is... yeah, so the Formula Student competitions are not like actually just races, but they're like a design challenge. So it's like a hypothetical customer has like approached a team to ask them to design us a race car that will do something and will be series producible. And this is like basically the a version of the customer evaluating how good that car is. So they go through the design stuff and why things are designed how they are and what the economics are. So that's this static events, and the dynamic events are where they like actually test the car. So let's listen back in here.
Starting off with acceleration. In the acceleration event, the car is over at distance 75 as fast as possible, starting from a standstill. This event is going to test straight line acceleration of the car. And trust me, it's quick. It's really beautiful.
Yeah, those are good.
So now it's straight line performance test. You might already guess what the focus of the next event is. The skip bed event is going to test corner performance of the car. To do so, the driver has to drive a figure 8 as fast as he possibly can, starting with 2 laps on the right side, then 2 laps on the left side. We then take the average strike both sides and base your score from them. This is always a very close competition, so every bit of performance requires skill counts. Now we move on to what you might refer to as actual racing. To us, this is called the autocross.
Yeah. So those first two are like actually like testing like more the performance of the car, and this autocross and endurance is like more testing like racing performance and how easy it is to drive or something like that, and fast, of course.
Finally, there's the largest event, the endurance. In the endurance, the start and finish line without not connected. You then must ride the track 20 feet long. You have to do so with two drivers. After 11 kilometers, you have 3 minutes to perform a drive. First driver gets out, second driver gets in, and you finish the event. However, there are more important perhaps in this event. The final category is the efficiency. The cars that have managed to finish the endurance are rated on their efficiency, and these final points are distributed accordingly. As you can see, not finishing the endurance has a drastic impact on the total amount of points and the chance of winning the competition. Besides the car has to be really fast, therefore also has to be really reliable.
And the point system is really interesting also.
Without a strong and dedicated team. Especially this year, they've shown what they're actually capable of. I would like to introduce you to our structure and a few of our members.
Okay, they are going to go through the
Team
team stuff. Nice.
consists of 70 of the most dedicated students, not just from Delft,
Yeah.
not just from the Netherlands, but from across the globe.
They have a really big team.
And different skill sets. Combining it all to create a team with the ability to face this challenge. Well, 70 team members, and believe it or not, there's actually some structure in there. 10 of those members are part of what we call the core team. These guys are responsible for structuring the whole project, setting up goals, making decisions on what needs to be done to achieve them, and planning out the entire year to make sure things are done when they need to be done. Well, that is the idea at least. Then there are the full-time engineers, a staggering 10 of them this year. These people spend their time entirely on engineering and don't have to bother with the whole goal and planning thing. A group of 60 members who, next to doing their studies, spend their precious free time on the team. And with some of them probably doing so too much. But hey, I'm definitely not complaining. Now you have a rough understanding of what the team functions like, I'm going to switch it up a bit. Instead of me rambling on about how proud I am of this team, I'm actually going to have some of them do the talking, asking them questions about their reasons to join the team and the experiences they have gained so far.
My name is Jeff Myers, and I'm the Chief Aerodynamics of BAT21. My name is Sander Althuis, and I'm the Finance and Supply Chain Manager of the DAT21 team. So that means I'm basically responsible for visualizing the car, taking care of the planning, and making sure our finances are healthy. My name is Tijmen Lee, and I'm the Chief Drivetrain and Suspension of the DAT21.
I'm José, and this year I'm responsible for PR and marketing of former Student Delft.
I am Menno Bergen. I'm this year's Chief Chassis for Student Delft. My name is Mitchell. I am an engineer in the chassis department of this year's former Student Delft. More specifically, I'm responsible for the shape of the chassis. I'm Stijn Leusing, and I'm this year's operations manager, which means I'm responsible for all the non-car stuff happening in and around the team. So why did I decide to join? Well, for me it started about 2 years ago when I saw an ad on a T Delft page about a position at a Ferrari Formula 1 team. And I realized, holy shit, this is very cool. So I need to work towards this because I wanna get to this position. And then I looked at options and what would be the first nice step to do. And that's why I came to former student. And from there on I joined, and I pretty much stayed within the team because it's a lot of fun.
I decided to join this team this year again, actually, because I was part of the team 2 years ago. And I really like the experience with working with different students and working together on one big project. And I really wanted to have that experience again, so that's why I decided to join.
So in the future, I really want to end up in this job in motorsports. Ever since I was a child, I really love motorsports, like Formula 1, but also NASCAR, IndyCar, a bit of everything. And I believe that from the students, especially here from the Student Team Delft, is one of the best ways to end up having a job in motorsports, especially in the field of aerodynamics. Like, aerodynamics is lovely.
What I learned so far during the first year, what I learned is that there's much more to creating a car than just engineering the car. It's also building the team, taking care of the 70 people that's in the team, making sure you have an office, which isn't given during Corona. And yeah, there's so much more you have to arrange to be able to engineer the car. And that's what I really did for the first time, along with my teammates. And that's what I learned the most from.
What I learned this year is working together with students that are in different departments or studies. And next to that, learning how to apply the theoretical stuff you'll learn at the university to a practical project that's actually going to be there and need to work because we need to win.
It's numerous things that I've learned so far. I think one of the most important things that I learned is that when designing, you really have to take into account how you're going to produce your product, because there's a lot of limiting factors during the production that can influence your design. And like within normal school projects, you don't really have that, because you never get to the part where you're going to produce your product. The farthest you will get is the design. But now it's not the case. Now we're actually going to produce a race car, so you really have to take into account all those limiting factors. Yeah, besides that, it's an end-to-end project, so you really get to experience all the phases that come into play when designing a race car. So it's the designing, the production, and eventually the testing and the racing.
Okay, so the audio and the presentation,
really special.
yeah, hopefully that works better. I did bump the, actually figure out how to bump that decibel up, so it is on plus 15 decibel now, so I am hoping that's okay. I mean, yeah, please let me know if you can hear that video well or not. I'm assuming there is going to be a little bit of echo because I have the mic here picking up the speakers that I'm listening from, so yeah, headset would be better, but unfortunately I don't have that set up here. I just have a gaming headset on another setup here, so yeah, if you still have problems hearing that, please let me know in the chat.
Within 9 months, we managed to design a car, build a car, test the car, and actually race the car, which is an incredibly short time frame. And yet, every year we managed to do that. And what makes it even more impressive is the fact that the entire team consists out of students. So from the top level management all the way to the engineers, we are all students. So we don't really have any experience with a project like this. And yet each year we manage to pull it off, even though we have a short time frame.
Yeah, that's also a huge learning experience.
It's the process that we go through. We start at completely nothing, at an idea of a car, and we work it all the way through within a year to a real driving car that we then get to compete with. And that's truly amazing. I think it's the people, which might be a cliche answer, but it's the will of every individual in this team to really make this race car the best car that has ever existed, and also the best Formula Student car that has ever existed. And like, everybody is ready to help each other. Like, at any time, if you send someone a message on Saturday evening, they're probably going to react within a few minutes, and there's a big chance as well that they're actually working on the car as well. So that's a truly unique thing, I think.
I think one of the best experiences that I had was during pub quiz that I and the chief of aerodynamics hosted together, and seeing that all the engineers get on so well, even though it is behind the screen and there's no real interaction.
Well, this year, like, we tried to make a new car, of course, during the pandemic, and one of the things I'm really proud of and really think, like, wow, this is a really good job we're done, is making the car lighter, making it more mechanical grip, and of course having it more downforce than previous year's car. And I think in that way we can be really proud of the design we delivered.
Well, one might say the fun things, with the team, but I think what might be the most special is the hard times, when you're solving a really difficult problem and there's no optimal solution and everyone's tired, it's late, and you really are in a hurry. And when you're in such a situation, it's not really fun, but afterwards, after you solve it and you've tackled the problem, that's really enjoyable.
Well, so the experience that stand out from previous years is of course competitions, but from this year it has been the design of the chassis. So when we finished the design of it and when we first saw the molds in real life, that's when the project really came to life.
I think the molds of the chassis, when they were made, when they were CNC'd, then that was the first like physical product that we have actually made. Like, it was also the first thing in my life that I designed like in a computer, and it actually became reality. So that was a pretty special thing.
Some of my personal highlights. I think what I really like is that through Student Delft, I've been able to get to know a lot of new people, even though we're currently living in difficult times with little social interaction. And,
by the way, guys, so yeah, please head over to the Delft former student. I don't have a link on that in the description here, but yeah, please head over to their presentation and hit a like on them. So yeah, be hugely appreciated.
I provided you with all of the necessary information that you need to have about our history, about our cars, about the competitions that we're going to race in, and not to forget about the amazing team behind all of this. So now it's time for that moment you've all been waiting for. I'm not going to have you wait any longer, so watch and please enjoy.
Their goal is also so good. I mean, they have one goal, and that's to like win the races, and yeah, they actually don't like, yeah, well, we want to compete and like improve on something, and like, no, they have like one goal, and it's, yeah, the best. Of course, probably multiple teams will do that also, but yeah, probably a lot of teams won't. So really, really good position to start from, and they have lots of good stuff to build on. So okay, crunch time. Okay, see outboard dampers with springs in the airstream, which will save weight probably, so yeah, there is a trade-off there with weight and aerodynamics. Do they, in the rear I'm assuming they have inboard or covered springs and dampers. Yeah, so those super complex hub pieces are what we manufacture for them. So let's see the rear. Come on, guys. Rear suspension. Oh yeah, and they're allowed active IRO, so they're allowed to use fans to boost it up. Okay, yeah, so the rear is much more critical for downforce stuff. So there they have inboard dampers and springs. That makes perfect sense. In the front, you say wait, because you have a lot of time to like sort of flatten out or like dissipate the turbulence or whatever that is called, so that the turbulence level like decreases when you get to the rear, and then you have all the wings and stuff to like help smooth out the airflow to those aero devices, and in the rear then you have like inboard springs and dampers to help with the aero stuff. So yeah, probably a good decision there. So in the front you can save weight, but in the rear it's more critical for aero because that's closer to the wing elements. So perfect sense. Yeah, those hubs are really nice.
What an amazing work has this team put together, and what an amazing design it is. Next up will be a more detailed explanation about the design itself and about the choices made. But that's not up to me though. I would like to hand it over to our chief engineer, Menno van Laarhoek.
That is and will be the DUT 21, a four-wheel drive electric race car that will be driving in a few months from now. I'll take you back to the beginning of this year, and we start off by defining three important pillars of design, which are necessary to win as a former student race car. Starting off with performance. In order to win, you need to be quick. It's that simple. And this is where most of the innovation is ignited in order to make a car quicker than ever before. But after that, a reliability aspect. In order to score points, you actually need to finish. Otherwise, well, you don't score any points. It's quite important. But on the other hand, it also makes the car quicker indirectly. Mostly because you can spend more time on track that's otherwise spent on fixing the car. That same line of thought, the car also needs to be maintainable. If you can fix the car quickly, that means you can spend more time on track and make the car quicker in the end. With those three pillars defined, we can start zooming in on the design of the Dutch 21, which mainly focuses on the performance pillar. That makes the car actually quick. A few ideas come to mind. For example, you might want your car to be lightweight, because it's easier to accelerate a lightweight car, therefore it will go quicker. You might want to be really quick with the road, which comes down to optimal placement
tire
of the
area and a better,
on that road.
friction,
You might
friction
also want to add
range.
some wings to help with that. Because the power output is limited by competition rules, you might also want a very efficient car, making most use of the power that you can store. And with those different aspects in the design of the car defined, we can go back to the beginning of the year, where most of the people in the project got involved and really start looking, okay, what am I responsible for? What different systems need to have different requirements? What kind of wishes do they need to have? With those different ideas defined, you can start looking into concepts, continuously keeping in mind the strategy of the aforementioned aspects. Once those concepts have been evaluated and a few promising ones have been chosen, you can really start designing. And that's where a lot of time is spent in CAD, computer-aided design. And because everyone's working from home, we were able to really efficiently use the 3D experience of the Dassault system to help us out. We're collaborating over distance a breeze. And what especially thanks the Dassault system for helping us out and being a long-term sponsor since 2004. Let's see what the result is of that design, starting off with the vehicle dynamics department. At the core of vehicle dynamics is performance. They do this from a very theoretical standpoint, analyzing all the different dynamics the car goes through. They help out all the different departments in making the right choices for extracting the most performance out of the car. A lot of this boils down to placing the tire optimally on the road. And it's no surprise that the tires are the only part that they're responsible for. I think we chose small tires that I've been on a car for years now, that are custom developed to get the driver to get the most out of those tires. And because we're an electric race car with 4 wheels and can control them separately.
Yeah, so this is really interesting. They have their own custom spec tires manufactured with Vredestein, which is collaboration with that tire manufacturer. So that's actually hugely beneficial. I mean, it does present lots of potential problems and more work and stuff like that, but it is very, very beneficial if you can fully take advantage of that. So that's really good. I'm assuming they're still using non-full dynamic simulations. So they're doing driver not in the loop type testing to see how important different aspects are in the car, which is, I mean, there are pluses and minuses to that. Of course, it's much easier to do lots of iterations and test different things, but in the end, it's kind of a trade-off. So if you do that, then of course it still takes time, but of course you gain knowledge that you otherwise don't have. Then again, if you focus heavily on doing what are these? So like driver in the loop testing, then you get all the setup testing and information on that done at the same time that you're testing the rest of the car. But there are trade-offs. Oh, let's listen in here again and see what the chassis stuff is.
This is not always possible in an optimal way. So a lot of trade-offs have to be made. It's a highly iterative process. Over 100 iterations go over it before the design is reached, as you can see right here. 6 links per wheel, transferring the forces from the wheel to the chassis through carbon fiber rods. This means that it's a very stiff yet lightweight solution. One of the biggest challenges each year is actually making the suspension fit with our small tires and reaching the optimal setup and transferring those to the chassis. This year there's been a focus on adjustability, which means that we are able to mitigate the uncertainties that come into play with tire modeling to make sure that we can find the optimal setup of placing the tire on the road during testing. Now that we have a chassis on wheels, it's time to make it move. For this, we have the drivetrain and powertrain department, where a number of different energy conversions take place. For this, we'll start off at the pedal box and take you throughout the journey throughout the car and to explain how the whole system works. The pedal box is where the driver operates the power and brakes of the car. This year we've made it adjustable in order to adapt for different sized drivers. When a driver demands a power output, the current starts flowing from the accumulator. This accumulator, a large battery, was about as much energy as an average Dutch household uses in a day. It's quite a lot. And it's all stored in this very compact design, which is possible due to the lithium polymer battery cells. This current flows from the accumulator to the motor controllers. And this is actually a new piece of our technology this year. These devices are responsible for regulating the magnetic field in the motors in order to generate a torque from an electrical input. Which means that all power is flowing through this little device.
Yeah, so they're using lithium batteries, which of course pretty much is the only option. So lithium ion, I mean, you can't get the power. So the power to weight ratio from lithium ion batteries is much less than lithium polymer. Of course, the energy density is higher again in lithium ion. So yeah, you have trade-offs. But then again, yeah, if you want to like recoup braking energy and stuff like this, they still might have capacitors. I'm not really sure how they do the brake regen, but yeah. Maybe we'll get through that also here. So continue to listen in here.
Transferred from motor to wheel for the planetary gearbox. So here. Because each of the motors can be controlled individually, it opens new possibilities for the vehicle dynamics department.
Ooh, yeah. So that was our parts over there. So the super complex like hub where you have a planetary gearing, engine mounting, wheel mounting on the other side, and the suspension point mounting. So lots of pieces in different angles that need to be extremely precise. So very, very happy to be working with from a Student Team Delft on those parts. So yeah, it saves them time and weight on the components and trying to what was it, 2018-19 I believe, when we looked at the parts of the DET 19 stuff, so figure out, okay, like we can incorporate like more separate parts into the same parts. They can be more precise, lighter weight, and yeah, have fewer parts. So that's always hugely beneficial, and just like basically go through like what kind of like how complicated parts are sort of easy to do. Or I mean, for us, I mean, we're specialized in doing extremely complex parts, so that's really good. Let's listen in again a little bit on the IRO.
Have a look at this wing element. In airplanes, we position them like this during takeoff, which means that incoming air will push the wing up during takeoff. But what we do is put this wing upside down, which means that there's a force towards the ground introduced. This force increases the grip of the tire, which means that we're able to accelerate quicker and go quicker through corners. So much so that we are actually allowing it to add almost 16 kilograms to the car. But one of the downsides of aerodynamics is that it's really dependent on the car velocity. Last year, a rules change was introduced, which allows us to use active aerodynamics, or for example fans, to introduce additional airflow into the car. This way, we're actually able to accelerate the airflow underneath the car and create additional downforce at lower velocities. An additional downside of aerodynamics is the increased air resistance. As you can imagine, if you put the wing element like this, you create also more surface area for air resistance. As a result, we decided to put a drag reduction system, or DRS for short, in the rear wing, which artificially changes the angle of attack of the wing elements in order to reduce its drag at higher velocities. And with this, we've been able to achieve new levels of downforce never before in a DOT car. Concluding, that is the DOT 21. Going back to the aforementioned design strategy, the DOT 21 is a car that's lighter, more efficient, and grippier than ever before.
Well, thank you, Menno, and what an amazing design it is. Now it's time for us to actually start realizing it and build the fastest car from Formula Student Team Delft to date. I would like to thank you all for watching, and I hope to see you all at the rollout of the DOT 21. Thank you very much, and goodbye.
Okay, good stuff on that presentation. So yeah, we'll be ending this. Also need to get back to other work, but let's quickly go through some parts that we did for them for 2019. So this is the hub assembly there. So you have the suspension mounting points. Oh wait, let's increase our size here a little bit. So yeah, this type of hub assembly piece. So have suspension mounting points here. I believe, yeah, there's here, so you could put some wait, how do I show this? So yeah, I have a disc. I'm assuming you can put like shims in between there and a mounting point there. And yeah, is this maybe the I don't remember if this is a front or rear. This might be either, actually, because yeah, I'm not sure if the tie rod or something is on here. But yeah, you have the electric engine mounts centrally here. And then these three surfaces here are for the planet gearing, and then you have this outer race here is for the ring gear. So yeah, and the sun gear, of course, is on the engine there on the planetary gearing. So these, I mean, from like our point of view, this part isn't even very complicated. So, but yeah, this is of course if you only have access to like 3-axis machines, then something like this gets really complicated because you have like precise angles that need to be done in different locations and stuff, and yeah, that makes it kind of difficult. But yeah, these are one of the really nice parts that they have on yeah, continuing with this sort of same type design on their DOT 21 car now also. And yeah, these are the suspension components. So can our autofocus on this? I guess so. Yeah. So you have you have carbon fiber tubes that go around these, and then they basically epoxy those into place, and you have a uniball here for the that then mounts to the wheel hub, or whatever that's called actually. And yeah, so if you're like, as you can see, there are like no like parallel flat surfaces where you can grip this in some kind of easy to do way to do manufacturing. So that kind of makes it difficult. But yeah, we did these like protrusion type things here to grip these. So they have 8 different parts, and yeah, all of them have these like these 2 like mounting pieces. These are not actually needed on the part for performance. This is just for manufacturing. But I mean, manufacturing of the parts is, well, maybe even more important than their performance, because if you can't manufacture them, you can't race them, so then you have no performance at all. But yeah, but this like really helps a lot. So this helps save like multiple hours of this, and if you need to do like a new iteration with slightly different geometry, then this is very easy to do, and do the yeah, mounting pieces for this. So basically we start from a solid block of aluminum, clamp that into a vise, and machine, or well, actually we machine this side first with these mounting pieces, then we just change out the jaws and can clamp like these with 2 jaws down like this, and yeah, with that and the vise, and then we can machine the top. So, or sorry, then we can machine the top here. So really easy, and this like geometry can be absolutely anything around here, and we still have the exact same mounting pieces, and so we can do new iterations and stuff like that very, very easy. So that also like helps reduce the likelihood of having issues, so, or running into unsolvable issues maybe. And yeah, that's also important. So if you can like take slightly higher risks with the design, then that's hugely beneficial, because you can save so much time on the design if you don't need to like double check every single detail, because they're not okay. In the unlikely event that we do make a mistake, then it's easy to fix that mistake. And yeah, you can definitely do that with these types of solutions. And yeah, mounting points for, yeah, I mean, this was relatively easy to mount, so there's nothing really special about this. But yeah, this part where you have like all sides are completely custom, but you still want to be able to figure out how to do this efficiently is interesting. But yeah, let's see. Hopefully the restrictions will start easing up a little bit, so that we can attend the rollout in person. I mean, that was a really nice event in 2019, so hopefully we can get back to that. But yeah, if not, might be doing a live stream again. We'll have to see how it goes. Hopefully we'll get the audio figured out a little bit beforehand, but it's kind of difficult also because when the stream starts, that's when we need to start streaming at the same time, and we don't have any audio to like trim that out with. So yeah, but hopefully at least the end part of this video at least had a good audio and had enough audio volume on the Dutch stream there. And of course, yeah, you can look back on this stream, and we'll probably be adding the direct link to their original stream also in this description, so you can jump over there and watch the full stuff there, and yeah, especially parts that talked over and stuff like that, so you can check that out fully. And yeah, one of the world top teams in formal student stuff, so definitely people we want to be associated with, and yeah, help them even further to figure out how to like get the most performance out of these type of complicated parts. I mean, we don't just do, so yeah, ElmerRacing, we don't only do engine components, but all kinds of racing stuff and different things. So yeah, lots of stuff to go through on this with them. But yeah, that's it for the stream. So thank you for tuning in, and thank you for commenting that we had audio problems. Otherwise, we might not have seen that. So yeah, but see you guys next time, and yeah, feel free to tune in and subscribe to us, and head over to so search for the Dut team and head over there and slam them a like also on their stream video there. So I mean, it's of course a student project, and the more views and likes they get, I mean, that's usually motivating and nice to see also. And of course always helps with the it's always like slightly political stuff inside of the school also. I mean, they have a really good setup there, so I'm assuming no big issues, but always better for the schools and stuff also to get some benefit, or like see that the student projects are getting like a big visibility, because that's marketing for the universities also. But yeah, that's it for now, and see you guys again next time. I was Oscar from ElmerRacing. Goodbye.